Hi, welcome back. In this video, we're going to talk about ADTTE. Okay, so if you open that specification here, this is a basic data structure, and ADTTE represents time to event analysis datasets. If you go check here, okay, so this is the basic data structure, and this has few variables because we need to check what are the predecessor variables and what are the derived variables. Okay, so let me minimize this part here. Okay, so here we have some predecessor. Let me filter out this one. Okay, so here I'm going to do the filtration by selecting this range. So let me select this one first, then I do the filter. Okay, so what I'm doing, I'm just trying to remove this predecessor first to check. So what are the variables we have to assign and what are the variables we have to derive. And you see there is a comment here, see value level metadata, and there are some asking for the set to days. Okay, so let me derive this one. So we consider, we also do this one, we'll make filter out. Okay, let me filter out this one here. Keep remove the predecessor. I also remove the 3 value level metadata. Okay, so I'll be having only 5 variables to derive, and the remaining ones we can get it from here, the param type, all this information will be getting from the value level metadata. Okay, so we go to the visual code, and here we open the previous the code was written. Okay, if I open the ADTTE here, all right, so here what I'm doing, I'm just trying to reset the previous outputs. If there is any reset outputs, I'm just trying to remove that part. And I'm using the Python 3.13.4, that is the kernel which I'm using here. Then I'm importing all this pandas and numpy and the other packages in order to execute this program. Okay, so next what I'm doing, I'm just trying to create one SDTM datasets macro is called class and objects. So this is what does it do? It basically in order to import any files in the SAS7 BDAT into the Python format. So for that reason we have to because the SAS7 BDAT I cannot read directly to the Python, so I need to convert first to the Python format, then I have to upload it. I have to import from there. Okay, applying this function, sorry, then the class and objects. So the similarly I'm doing for the Atom datasets as well, so the same process. So next I'm importing the both ADSL and ADVS. Okay, so if I check the both dataset, I have ADSL here, so it will be having around 116 rows and 55 columns. Okay, so and also if I want to check other dataset like ADVS here, so this one will be having almost like 7,000 rows and 43 columns. Okay, let's continue with this one here. First what I'm doing, I'm trying to sort the values by unique subject ID, and then I'm trying to reset the index to make sure the sequence are correct, remove that old sequence and coming back to the new ones. Then what I'm doing, I'm just trying to the param cd, I'm just trying to filter it out, because when you check the value level metadata, so this is I'm just trying to do with the temperature data for now. First parameter will be the temperature data set. Okay, fewer symptoms. So here let me go to the specification here. So I keep that C value level metadata. I'll remove the other part. Okay, so I'll remove these ones. I'll remove all these 5 of them. So I'll keep only the value level metadata. So here we have to derive the param, paramen, param cd, parcat, param type, aval, ADT, and sensor, and the event or sensoring description and sensor date description. So for these ones we have to go to the value level metadata. Here we will be having the param, paramen, parcat, param type, aval, avalc. So first what we do, we just trying to filter out first param cd equal to temp, then advs ady less than or greater than or equal to 1. Okay, so that is the same filtration I have done. Then I took the few variables here, unique subject id, adt, ADY, analysis visit numeric, and analysis visit param cd, param, all these variables I have selected. Then what I'm doing, I'm just sorting them based on the unit subject id and aval and a visit and analysis visit. Okay, so then the maximum I'm taking the last record of that group from that parameters. Okay, if I check here, So set to 0 if a subject has a record when param cd equal to t temp. So basically I'm taking the maximum temperature, that is the maximum temperature. Last record means the particular subject has the maximum temperature. Then what I'm doing, I'm just combining this ADSL and the maximum temperature by unique subject ID in the left join. Okay, so if I run it, so when you check the combination of temp, so if I go check the combined temp here, so here what I'm saying is this particular subject. Okay, if I go to the last wall category here, so the person for that particular subject will be having 36.9 temperature. So this is the maximum temperature for that particular subject. Okay, so this is the way we have to calculate the maximum temperatures. Then what I'm doing, I'm just trying to create one function for process fever events, and I'm giving as a row. So if row match, so the match here, it is basically it works for the both A and B data frames. Okay, so this is by if you are combining the two data frames, so it has to be have this condition as both, either left only or right only or both. Okay, so then in sensor will be, I'm giving as a 0, then aval will be the ADY, the data set of analysis day, and event description will be the maximum temperature, and ADT aval sensor event description giving as a missing now, and the return row. So here for param cd, so param cd will be favorism, so I'm copy this part and applied here, and param will be the fever symptoms, and param n will be the 1. Okay, and the time to event, paracat will be the time to event, then param type will be the derive, and the and aval c is missing, and ADT will be the set and analysis ADBT function occurrence. So this will be the here, ADTF will be the missing. Okay, so ADTF will be the missing here. If I go check here, so ADTF, I don't have this variable. Okay, ADTF will be the missing. Okay, maybe I have to go check here. Okay, so here, okay, so here we have when I check the specification here, in the ADTF is based on the ADT. So the ADT is the so see the value level metadata. So if I go check, ADT should be the ADT is the first occurrence of the maximum severity, where ADB is equal to temperature. Okay, so here we already took the ADT because we are considering the maximum temperature for that particular parameter. So since the ADT there is no partial date, so we consider for now is as a missing, because when you check the combination date, so they are no, say they have missing values, but there are no partial dates are present, so we're not doing any imputations in this specification here, so we keep it as a missing for now. And the NL01 flag will be the Y. So if I check the NL01 flag, if I go to here, so NL01 flag will be the is set to Y. Okay, so that is the comment for giving this one set to Y. So similarly we have to do with the next parameters. The next parameter will be the respiratory, so the elevated respiratory system. So what we're doing here, we're just trying to increase if there is a maximum respirator and ADY is greater than or equal to 1, set to maximum respiratory for the event description. So we did the same thing, we filtered out and we consider that ADT as a maximum. Then what we're doing, we are sorting the variables by using the subject ID 1 and AVZ10. Then we're we're trying to reset the sequence. Then we group by unit subject ID for the maximum severity response respiratory. Then we combine with the maximum severity, and instead of taking the last start, we group by the we're taking as a combination of by group. So we're taking as unit subject ID. Okay, so then once I run this part, combination of I will show you what does it means. If I go here, combination respiratory, so in the combination respiratory, if I go for aval value, so this aval value will be the maximum for that respiratory elevated for that particular subject. Okay, so here we're considering that maximum response respiratory. Okay, and then we merge with this ADSL by using unit subject ID, then in the left join. And similarly we do the same process. We're creating the one function, the process respiratory events. Then what we're doing, we're creating that based on the specification. We allotting the based on the value level metadata, like param n will be the 2, parcat time to event arrive, and the sensor equal to 0 for oval. Okay, so here we're doing the similar pattern. Then ADTF will be the missing, oval C will be the missing. So then we can concatenate with the both combination 1 and combination 2 in the all data new as a new data set. Okay, next what we're doing, we go to ADTTE. Here we have our units, so that is set to days. Okay, so that it is we considering days. Then start DF and sensor TDC will be the missing. We'll keep it as a missing here for now. So these two, because here in the value level metadata, if we scroll down here this is a missing. And also what is the next one, start DTF. So this is also we kept as a missing. Okay, so I don't have that here, maybe. Okay, let me check here if we have. Okay, so we both these variable we keep it as a missing for now, missing. Okay, then what we doing here, we sorting the variables, all the data set, all data, we sorting the values by unique subject ID. Okay, so then we consider all the columns, whatever the columns we required. So the remaining ones, the predecessors will be coming automatically from the ADSL. So for example, so all these ones are coming from ADSL. So I'll keep it this part as a like that. Then so then param and param, all these param type aval unit, so these ones we keep it, we all done this part as well. And the start date, so will be the TRT SDT, which is automatically the predecessor. Okay, so I forgot to run this part here first. So I have run it, the function, then I have run this respiratory elevated ones, then I have run this function for the respiratory events, then I have run the all data. So in all data, so I'll be having, so if I refresh this data, so I will be having all those required variables, event description, param and param cat, param type, avalc, and all 01 flag and aval units. So even the sensor will be having this part 0. Okay, so then I'm considering all the required variables as per the specification. Then I applied for those specification var to var for the final for all data columns. So I'm creating as available vars and missing var the two data sets. Then I'm applying for the available vars as ADTE TTE as a new as a final data set ADTTE. So here we'll be having the final data set along with the columns. Okay, I mean along with the 232 rows and 34 columns. So now we have to apply the labels. So here I'm applying the labels by using column labels. Okay, in the column labels I'm applying all this. I just taken from that from here. Okay, I may miss this part. Okay, so what I do, I just copy, I put here. Okay, so I put D2, then E2. Okay, so I think I have selected all of them. I'm not sure why it's coming like that. Okay, perhaps I may miss something. Okay, anyway, so you copied that all the labels here. Okay, you paste it here, then you apply those columns here, those columns to the ADT attributes. And then if you want to check it, and you can able to check all this the values are present here, the treatment and treatment, actual treatments, all these are coming there. So then what I'm doing, I'm just trying to output the final data set in the CSV format. So here I'm seeing the ADD is successfully completed along with the 232 subjects and 34 variables. So this is the dimension of that particular data set, 232 rows and 34 columns. So these are the columns are present in that particular the final data set. So if I go here, if I go and check for the so Adam data set, so I'll be having ADTTE. Okay, so all these variables and along with rows records are present, and it will be the final data set for the ADTTE. Okay, hope you understand. This is time to event, and it will be considered as efficacy data sets as well. Okay, thank you so much for listening.